So let's move on to the questions of chemical equilibrium now, and this is the first question, which says the reaction PCl5, which gives PCl3 plus Cl2, takes place at a temperature of 600 degrees Celsius in a closed vessel of volume 2 liters. At equilibrium, the number of moles of PCl5, PCl3 and Cl2 are 1, 2 and 2 respectively. तो 2 लीटर का वॉल्यूम है और इसमें मोल्स ऑफ PCl5, PCl3 और Cl2 हमें दिया हुआ है 1, 2 और 2 मोल्स रिस्पेक्टिवली. तो हमें पता करना है इक्विलिब्रियम मोलर कॉन्सेंट्रेशंस, इक्विलिब्रियम मोल फ्रैक्शंस एंड इक्विलिब्रियम कांस्टेंट Kc विथ यूनिट्स और Kp और Kx भी विथ यूनिट्स हमें पता करना है. तो हाउ आर वी गोइंग टू मूव फॉर दिस क्वेश्चन?
Let's see what has been given to us in the question. The temperature is 600 degrees Celsius. The volume is 2 liters. We know that the number of moles of PCl5, PCl3 and Cl2 are 1, 2 and 2. And we know that the molar concentration is the number of moles divided by the volume of the reaction vessel. So, at equilibrium, the concentration of PCl5 will be 1 upon 2.
Right.
Which is 0.5 molar.
तो उसमें नंबर ऑफ मोल्स हमने ले लिया और नीचे वॉल्यूम ले लिया, तो उससे 1/2 आ गया 0.5 मोल.
Exactly.
Molar. Yeah.
Concentration of PCl3 will be 2 upon 2, which is 1 molar.
Yeah.
And concentration of Cl2 is again 2/2, which is 1.
Right.
This was part A. Let's come to part B. The equilibrium mole fractions. The total number of moles at equilibrium are 1 plus 2 plus 2, which is 5. We know that mole fraction is number of moles upon total number of moles. So, for PCl5, the mole fraction will be 1 upon 5, which is 0.2. For PCl3, the mole fraction will be 2 upon 5, which is 0.4. Similarly, for Cl2 chlorine, the mole fraction will be 0.4.
Right.
For part C, that is, we need to find Kc with the appropriate units. We know that Kc will be PCl3 into its stoichiometric coefficient, which is 1, into Cl2 upon PCl5. Concentrations. Kc is in terms of concentration. We know the concentrations of all the three reactants and products. For the concentration of PCl3
is 1. Yeah.
For Cl2 is 1 again.
Yeah.
And for PCl5 it is 0.5.
Right.
So we get Kc as 2.
Right.
And we know that in the theory we went through the units. It is mole per liter raised to the power delta Ng.
Right.
Let's find out delta Ng. Delta Ng is the gaseous moles in the product, which is 1 plus 1 minus the gaseous moles in the reactants, which is 1. So we get 1. So Kc will be 2 mole per liter.
Right.
Raised to the power 1, which is mole per liter.
Yeah.
Now we come to part D, where we need to find out Kp and Kx with their units. We know that Kp is equals to Kc into RT raised to the power delta Ng. So, in the previous part, we found out the value of Kc, which is 2. We know the value of R, which is 0.082. And we know the temperature, which is 600. But we need to put it in Kelvin.
Right.
So, we'll add 273.
Okay.
And delta Ng is 1. So, 1 for that.
Yeah.
So, the value is 143.172.
Okay.
And the units are atmosphere raised to the power delta Ng, which is 1.
Right.
Next, we need to find out the value of Kx, which is the equilibrium constant in terms of the mole fractions. We know the relation between Kp and Kx. Kp is equals to Kx RT raised to the power delta Ng. So it's very simple. We just put in the values. Kp is 143.172. We need to find out Kx. We know R 0.082 and we know T, which is 600 plus 273 raised to the power 1. Right. So we can solve this for Kx. If we solve, we will get 0.8.
Oh, okay.
And it will be obviously dimensionless, unitless, because mole fractions have no units.
Alright. Okay. So this was question number 1, which was relatively quite simple. wherein we had to understand how do we use the formulae and find out Kc. First of all, find out the concentration, then find out the mole fractions, then find out Kc using those concentrations, and then finally find out Kp and Kx with the given formula. Alright, so let's move on to question number 2. Alright, so here we have question number 2 with us, which says the reaction N2 plus 3H2, which gives 2NH3, takes place in a closed vessel of volume 20 liters at a temperature of 500 Kelvin. The equilibrium constant for the reaction is 1.7 into 10 to the power 2. At a certain instant, the number of moles of N2, H2 and NH3 are 4.2, 2 and 10 respectively. Is the system in equilibrium? If not, then find the direction in which the reaction will shift. हमें दिया गया है रिएक्शन, हमें यह भी दिया है कि उसका वॉल्यूम है 20 लीटर और टेम्परेचर है 500 केल्विन और उसका इक्विलिब्रियम कांस्टेंट भी हमें दिया गया है. फिर एक किसी पर्टिकुलर पॉइंट ऑफ टाइम पे हमें यह बताया है कि N2, H2 और NH3 के कितने मोल्स उस पर्टिकुलर सोल्यूशन में होंगे. सवाल यह है कि क्या ये सिस्टम इक्विलिब्रियम पे है, और अगर नहीं है तो वो किस डायरेक्शन में जाएगा, रिएक्टेंट से प्रोडक्ट की तरफ जाएगा या प्रोडक्ट से रिएक्टेंट की तरफ जाएगा. सो श्रुति, हाउ आर वी गोइंग टू प्रोसीड इन दिस पर्टिकुलर क्वेश्चन?
We'll calculate the reaction quotient, which is Q, and we'll compare it with the equilibrium constant Kc.
And what's the difference between Q and Kc?
See, Kc is calculated at equilibrium.
Right.
We talk about Kc only at equilibrium, and the reaction quotient is calculated at any
point
instant
of time.
Right. At any point of time.
Right.
And when Q is equals to Kc, we say that the system is in equilibrium.
Okay.
So we'll calculate Q, which is given by this expression for the particular reaction here. It will be given by this expression.
Right.
So for this, we'll first calculate the concentrations. So for ammonia, it's given to me that the number of moles are 10 and the volume is 20. So the concentration is 0.5.
Right.
For nitrogen, it is 4.2 by 20, which is 0.21.
Right.
And for hydrogen, number of moles are 2
by 20,
and the volume is 20, so it is 0.1.
Right.
So
these
these are
is
the
the concentration,
concentrations.
which is moles per liter.
Yeah,
everything.
moles per
Right.
liter.
Okay.
And the unit is molar. Fine. I'll substitute these values in the expression for the reaction coefficient. So I get 0.5
5 to the power
upon 0.21 into 0.1,
yeah,
which is 1.19 into 10 raised to the power 3.
Okay. What is the
Kc,
unit for that? Shouldn't we write the unit there?
Yeah. The unit will be mole per liter raised to the power delta Ng. The unit will be same as Kc.
Yeah.
So, and delta Ng we
minus
know is minus 2. So here the unit will be liter per mole square.
Okay. Sure. Okay.
Yeah.
So what is the Kc which is given to us? The Kc which is given to us is, I'll take it from here, 1.7 into 10 to the power 2.
Okay. The Kc is 1.7 into 10 raised to the power 2. Now if we compare Q with Kc, we find that Q is not equal to Kc. That means the reaction is definitely not in equilibrium.
Yeah.
Okay, that answers the first part of the question. We move on to the second part, where we need to find out the direction of the reaction. Now, since Q is greater than Kc, we know that the reaction will shift backwards. Why? Because we need to understand that every reaction has a tendency to retain its equilibrium.
Okay.
So when Q is becoming greater than Kc,
Q is becoming greater than K. Okay.
That means to attain equilibrium, I need to decrease the amount of product and increase the amount of reactant.
Right.
So the reaction will shift in the backward direction so that we approach Kc.
Exactly. So since in Q and Kc, in both the terms, in the numerator you have products and in the denominator you have reactants, and what we are getting is how much ever in Kc you should have the numerator, you have more than that in Q, which means you need to reduce that, which means the product is going to be lesser and the reactants is going to be right. Okay, so it'll be in backward direction. Right. Alright, so this is how we find which direction is a reaction going to go from. So for that you need to calculate Q and compare it with Kc, and if Q is more than Kc, then it's going to go backward, or otherwise it's going to go forward. So that was question number 2. Let's move on to question number 3, which says 1 mole each of A and B are taken in a closed vessel of volume 5L. And following reaction is allowed to take place, which says A plus B gives C plus D. 0.5 moles of C are present in equilibrium if instead of 2 moles of A and 1 mole of B are taken at the same conditions. Find the equilibrium concentrations of all reactants and products at equilibrium. Alright, so how are we going to approach this question?
Yeah, so the following reaction is taking place. A plus B is in equilibrium with C plus D, and we know in case 1, we know that we take 1 mole each of A and B, and initially obviously 0 moles of C and D are present.
Right.
Now
so that's at time t. So
at time t is equals to 0.
Yeah.
This is at time t is equals to, so at time at the time at which the reaction reaches equilibrium, I can write the number of moles of A left are 1 minus X. So X moles react. Since the stoichiometric coefficients are same, then X moles of B will react, X moles of C will be formed, and X moles of D will be formed. So we talk in terms of concentration. So we'll find out the concentrations of all the substances.
Right.
So the volume given is 5 liters.
Right.
Concentration of A will be 1 minus X upon 5. Similarly for B,
by 5, and everything will be 5.
Now, the major concept that I'm going to use in this question is that Kc is only a function of temperature and nothing else.
Right.
Okay, so even if I change the initial concentration of the reactants, the Kc will not change.
Absolutely.
Right, since the temperature is not changing at the same conditions we saw over here. So so I'm going to calculate Kc for the first case, which will be concentration of C raised to the power 1, because the stoichiometric coefficient is 1, into A into B. And I'll substitute all these values over here. So I'll get X by 5 into X by 5 upon 1 minus X by 5 into 1 minus X by 5,
so
which will give me X square upon 1 minus X
square
whole square, because all the 5's will cancel. Right? So this I will name as A, equation A.
Okay.
Case 2 now. So the same reaction is taking place at the same conditions. The only difference is that the initial moles of A are 2 now, and the moles of B are 1. 0, 0 again. Then now suppose Y moles of A get converted. So Y moles of B will get converted, and Y moles each of C and D will be formed. This is at T equilibrium. Right? I'll find out the concentrations now. The volume remains the same. So the concentration will be the number of moles divided by 5. Right? Now I will find out Kc for this case, which will be Y by 5 into Y by 5 upon 1 minus Y by 5 into 1 minus Y by 5.
2 minus Y by 5.
So it will be 2 minus Y. I'm really sorry. It will be 2 minus Y. So we get Y square into 1 minus Y into 2 minus Y.
Right.
Now I can equate. Let's say this is B. I can equate the values of Kc we obtained in both the cases, because the temperature is same. So I'll equate them.
So you can change the color again. That will be easier.
Y square.
So I'll just change the color.
So Y square upon 1 minus Y into 2 minus Y is equals to 0.5 square upon 1 minus 0.5 square.
Right.
Why? Because it's given in the question that in the first case, the number of moles of C present at equilibrium are 0.5.
Right.
And X is 0.5. That means X is 0.5. So I just substituted the value of X in the equation A. This will be 1, because 1 minus 0.5 is also 0.5. So this will cancel out. I can solve. I'll obtain if I solve this, I will obtain this equation. Y square cancels out.
Okay.
So I get y is equals to 2 by 3.
Right.
The question demands us to find the value of the concentrations of all the reactants and products. Right. So it's fairly simple right now, because I know the value of y, which is number of moles now.
Right.
So
Sure.
yeah.
So now that we know the value of y here, the question demands us to find the equilibrium concentration of all reactants and products at equilibrium. So equilibrium concentration here is 2 minus y by 5, 1 minus y by 5, y by 5, y by
And
5.
y by 5.
And
So
if we substitute the value y here, we'll get our answer, right?
Yeah.
Alright, so what we learned here is that Kc is a function of temperature and nothing else. So since the temperature here is same, only the initial concentration of A and B is changing, Kc would still remain the same, and we can substitute the value of whatever is given. And it said let's start A with 2 moles instead of 1 mole, so we took 2 moles and then we subtracted y, whichever is going to be produced in C and D, and that's how we were able to find the value of y, and hence we could find the concentration by replacing the value of y. Alright, so that was question number 3.
So now we come to the fourth question for the chapter, that goes something like this. For the reaction NH4Hs in solid state in equilibrium with ammonia in gaseous state and H plus H2S in gaseous state, taking place in a closed vessel in which ammonia is present with a pressure of 0.5 atm. Now we are given Kp to be 0.11 and we need to find the total pressure in the reaction vessel at equilibrium. So how are we going to do this question?
Yeah. So let's see what has been given to us. Let's see what has been given to us first. We know that this reaction is taking place, and we know that initially at time t0 the pressure of ammonia present is 0.5 atm, right? H2S is obviously 0, and let's say we start with 1 mole. Now at equilibrium, let's say x moles of NH4HS gets consumed, and we'll talk in terms of partial pressure here, so plus x and x. Now we need to keep in mind that solids are not included in the expression of Kp or Kc. So we're given Kp to be 0.11, and we know the expression for Kp for this reaction will be partial pressure of NH3 into partial pressure of H2S. Solids are not included. So when I substitute these values in the expression for Kp, I get this equation. Now I'll get a quadratic equation which I can solve very easily. This will be the quadratic that I'll obtain, and when I solve it, I will obtain x as 0.17 atm. Now I need to find out the total pressure at equilibrium, which will be the sum of the partial pressures of the two gaseous components, which is ammonia and H2S. So I know that the pressure of ammonia at equilibrium is x plus 0.5, which is 0.17 plus 0.5, which is 0.67 atm. Similarly, the partial pressure of H2S at equilibrium is given by x, which is 0.17 atm. So the total pressure at equilibrium will be nothing but the summation of the partial pressures of ammonia and H2S, which is 0.67 plus 0.17 atm, which is 0.84 atm.
Okay, so this was the solution. I wanted to ask, why exactly don't we include the partial pressure of solids?
See, the partial pressure of solids doesn't change much during the reaction, and by convention, we always take the activity of solids and liquids to be 1. So, yeah.
Okay, so basically this was an easy question. The catch here being that we don't include the partial pressure of solids and liquids. And as you can see, if you're being careful with the quadratic, you could easily solve this question. And this is the level of questions that actually come in JEE from this chapter. Easy to do once you need to practice. So this was question number 4. So here comes question number 5, that goes something like this. Ag plus NH3 is in equilibrium with AgNH3 plus, and the K1 for this reaction is given to be 3.5 into 10 to the power 3. And we are also given another reaction that says AgNH3 plus NH3 in equilibrium with AgNH3 whole twice plus, and K2 for this reaction is given to be 1.7 into 10 to the power 3. Now we are supposed to find the equilibrium constant for the reaction Ag plus 2NH3 giving AgNH3 whole twice plus. Now in such type of questions, it's kind of obvious that one may get confused giving so many reactions, but it is actually a very easy question. We'll just see how to solve it.
So basically we are given two reactions, and if you notice carefully, you will find that if you add these two reactions, you'll get the required reaction. Okay, so I will write down the equations. This is the first reaction given to me, and the second reaction is something like this. I'm sorry. Yeah, this is NH3, AgNH3 twice plus.
Yeah.
If I add these two reactions, we'll see that this and this will get cancelled. Okay, and these two will get added. So I get Ag plus 2NH3 is in equilibrium with AgNH3 twice. Now, we all know that when we add two reactions, then the equilibrium constants get multiplied. And it's kind of obvious, it's very easy to derive actually. If you write the expressions for the Kc of these two reactions and then take the reciprocal, multiply them, the terms will cancel.
Exactly,
so
that's a mathematical
yeah,
thing.
so it's really an easy question, and it came in JEE 2006, I think.
(1.7 into 10 to the power 3).
So yeah, the answer is 5.96 into 10 to the power 6. Similarly, if you subtract one reaction from the other, then the equilibrium constant will be the reciprocal of the two reactions. And if you say there's a reaction and if you multiply the entire reaction by say 2, then the Kc will be the square.
Exactly.
Right.
So these are some properties regarding the Kc. They are often asked and you just need to memorize them, and often how we deduce them, that is not really that important, as it is important to just memorize the formulas.
Yeah, because it saves time.
Exactly. So this was question number 5.